Okay, girls, we're going to finish this unit topic number 3 on the unit circle via a podcast since we've run out of time in class to get this finished. Um, One of the things we talked about last week was definition of a unit circle. Okay, so remember, unit in unit circle means the radius is 1. So when we rotate our initial ray to one of the quadrantal angles, remember those are angles that fall on the x or y axis, you just need to think of the coordinate as an ordered pair with a radius of 1. And so we went through these points in class last week. So I just want to do a sample problem to illustrate some of the differences in the 6 trig functions when your angle measures one of the quadrantal angles. So if we look at an example, it says find the 6 trig functions for easy values of t. And it says t equals pi. So that means we're rotating our initial ray pi radians, which is 180 degrees. And we end up on the negative x-axis where the ordered pair is -1, 0. So if we want to find the sine of pi, you all remember that sine is the same thing as the y value, and our y value is 0. If we want to find the cosine of pi, if you remember, cosine corresponds to the x value, and the x value is -1. And then tangent is our y value over our x value, which would be 0 over -1, which is 0. Then when we get to the other 3 trig functions, if you recall, which are the reciprocal trig functions, cosecant is the reciprocal of sine. So we need to stop and we need to think, what is the reciprocal of 0? Any number can be written as a fraction by just putting it over 1. So if we think of 0 as 0 over 1, the reciprocal would be 1 over 0. And the same is going to happen for cotangent. If we think of the reciprocal of 0 is going to be 1 over 0, and 1 over 0 is undefined. You cannot divide by 0. So for cosecant of pi and cotangent of pi, you should have undefined. And then last but not least, for secant of pi, the reciprocal of -1 would just be -1. So anytime the value of one of the trig functions is 0, when you go to find the reciprocal trig value, if sine, cosine, or tangent are equal to 0, then the reciprocal trig value going to be equal to undefined. Okay, moving on. If you know the value of sine, cosine, and tangent in quadrant 1, you can find them in all 4 quadrants. Just find the reference angle and then make sure you think of the correct sign, positive, negative, so on and so forth, depending on what quadrant you're in. Okay, and we're going to do an example of that in a minute. But first, I showed some of you this, and most of you indicated that you had talked about this in Algebra 2. The phrase, all students take calculus, if you focus on the first letter, the ASTC, all students take calculus, it can help you, depending on what quadrant your angle is in, get the correct SIGN, sign of the trig function. So the phrase all students take calculus tell you which trig functions are positive, okay? So all for the first quadrant means that all the trig functions are positive, sine, cosine, and tangent in the first quadrant, okay? And then obviously the reciprocal trig functions would be positive as well. Then if we go to S, so you're going around from first, second, third, and fourth quadrant. So S would take us into the second quadrant, and only the sine trig function is positive in that quadrant. Cosine and tangent would be negative. And then if we go to the T and take, that means only tangent is positive in this quadrant, and so sine and cosine would be negative. And then C for the fourth quadrant means cosine is positive, therefore sine and tangent are negative. So if you don't like remembering the phrase all students take calculus, you just have to remember that sine goes with the y value, and y values are positive in the first and second quadrant. Cosine is the x value, and x values are positive in the first and fourth quadrant. And then obviously tangent depends on the sign, S-I-G-N, of the sine and cosine function. Okay, so if I were asked to find the sine of 315 degrees, I know 315 degrees. If I rotate my initial ray, my terminal ray falls right here. And I have a 45-degree reference angle, because if this is 315, then I have 45 degrees to get back to the x-axis. And so I know the sine for a 45-degree angle is rad 2 over 2. But I am in the fourth quadrant, and the y value is negative. Cosine is rad 2 over 2, and I'm in the fourth quadrant, and the x value is positive. And then once I know sine and cosine, I do y over x, or sine over cosine for tangent, and that would be -1. Okay, so all I did was find my reference angle of 45 degrees. I know the sine and cosine of a 45-degree angle, and then I can take it from there. All right, I'm not sure if you were shown this in Algebra 2, but I wanted to show you a quick trick on how to remember the sine and cosine of the common angles, basically the angles in quadrant 1, because we just said if we know all the ordered pairs and the values of the trig function in quadrant 1, then we can find them in any other quadrant. So one quick way to do this is, there's a pattern here, and I'm just going to write it out and then we'll talk about it. So for the sine of any angle in the first quadrant, including the quadrantal angles of 0 and 90 degrees, numerator is in ascending order, and the denominator is always 2. And if you think about it, square root of 0 is 0, square root of 1 is 1, so that simplifies to 1/2, and then the rad 2 over 2 stays the same, the rad 3 over 2 stays the same, and then obviously square root of 4 is 2, and 2 divided by 2 is 1. Okay, and then for cosine, instead of the numerators going in ascending order, they go in descending order. So rad 4 over 2, rad 3 over 2, rad 2 over 2, rad 1 over 2, and rad 0 over 2. And again, rad 0 over 2 is going to simplify to 0. Rad 1 over 2 is going to simplify to 1/2. The rad 2 over 2, the rad 3 over 2 stay the same, and rad 4 over 2 simplifies to 1. So that's just a quick, easy way that you can remember the sine and cosine of the common angles in that first quadrant. Okay, I don't think I'll have time to do both of these examples, but let's do part A, evaluate the 6 trig functions for each real number. I'm a very visual person, and so I'm just going to draw a picture. It helps me emphasize what quadrant I'm in. I'm going to rotate my initial ray 2 pi over 3 radians, which I know puts me in the second quadrant. I'm going to think about what my reference angle is. That would be pi over 3, or 60 degrees. And then I want to find the sine of 2 pi over 3. And I know the sine of a pi over 3, or a 60-degree angle measure, is rad 3 over 2. And I'm in the second quadrant, so I know sine is positive. Cosine of 2 pi over 3 is then going to be 1/2, and I'm in the second quadrant, so my x value has to be negative. And then if I do tangent, that's just sine over cosine. And so if I simplify, the sine over cosine, the rad 3 over 2 divided by the negative 1/2, I'm going to get negative rad 3. I always do sine, cosine, and tangent first. Now when I go to do cosecant, secant, and cotangent, all I have to do is do the reciprocal. So for cosecant, it's going to be 2 over rad 3. And then, of course, I have to rationalize. So we'll get 2 rad 3 over 3. Secant's easy. Reciprocal of negative 1/2 is negative 2. And then cotangent would be negative 1 over rad 3. And again, we have to rationalize. So we get negative rad 3 over 3. I'm not going to do 7 pi over 4 because really that's the same thing as 315 degrees, and we did that in a previous example. All right, moving on, find the exact values of the 6 trig functions of theta, and they give us an ordered pair, negative 4, 3. So if you look, I already have a diagram set up. I know that's where the point is. I don't think it really matters if you label this side of the triangle negative 4 or positive 4. Technically, the length of that segment is only 4 units. So in order to find the sine of theta, this is not a unit circle because the radius or the hypotenuse would be 5 by Pythagorean theorem. So when I have a picture like this, I tend to use SOHCAHTOA, or you can use y over r. But either way, sine of this angle would be 3/5. Cosine would be negative 4/5, adjacent over hypotenuse, or x over r. And then tangent is y over x. So that's going to be 3 over negative 4. And since we don't have any rads, our reciprocal trig functions are going to be super easy. So cosecant would be 5/3, cosine would be negative 5/4, and tangent would be negative 4/3. So that one was pretty straightforward. Okay. All right, real quick, using your calculator to evaluate trig functions for angles that aren't multiples of 30 or 45 degrees, make sure you're in the correct mode. So you would need to go to settings and switch to the appropriate mode, either degree or radian mode. Okay. It's nice because with the new operating system in the top right corner, it should tell you DEG if you're in degree mode, or it'll tell you RAD if you're in radian mode. So if you are asked to find the sine of 217 degrees, you obviously want to be in degree mode, and you can just punch it in. If they ask you to find the tangent of 3.21, there's no degree symbol, so that's 3.21 radians. So you'd want to make sure you are in radian mode. Okay, one last example. We have an acute angle, and we know the cosine of that angle equals 0.8. If it's an acute angle, that means we are in the first quadrant, and I'll go ahead and draw my right triangle. It tells us the cosine of that angle equals 0.8. Well, another way to think of 0.8 is 8/10, which reduces to 4/5. And then we know that cosine is x over r, or adjacent over hypotenuse. And then if we use Pythagorean theorem, we know the missing side would be 3 because that 3, 4, 5 Pythagorean triple. So now if I want to find the sine of this angle, we would know it would equal opposite over hypotenuse, or y over r. And then if we want to find the tangent is, we could either use sine over cosine, or we can use opposite over adjacent, and that will give us 3/4. Okay, we do have one final example, and it's sort of working backwards. I want you to find theta, the angle measure, when you know that the sine of that angle measure equals negative 1/2. Well, as soon as I see the 1/2, my brain is thinking 30 degrees because I know the sine of 30 degrees equals 1/2. And so where is it going to equal negative 1/2? Well, sine is negative in the third and in the fourth quadrant. And knowing that the sine of a 30-degree angle equals 1/2, that means my reference angle in both the third and the fourth quadrant is 30 degrees.